So now we're going to talk about a quadratic function. So it's similar to a quadratic equation. It's just that we have this function notation. And so we could actually, graph this. And at some point later on, we'll do that where we graph these quadratic functions because it's in terms of y equals x squared minus, in this one, x squared minus 2x minus 8. Okay, so you can think of it that way. But right now we're not going to do the graphing, so we don't have to worry about that. And we're going to work with the function notation. So part A says find x when f of x equals 7. So in other words, 7 is what is f of x is being replaced with. So we get this equation, x squared minus 2x minus 8, the function part, and it equals 7. So now it's a quadratic equation like we were solving before. We're going to subtract 7 from both sides to set it to 0. And remember, in this equation, we're solving for x, but that's what part A says, find x. So we look at that trinomial, and we're going to factor it. It factors into x minus 5 and x plus 3, so you can think about that factoring. And so we get either x minus 5 equals 0, or x plus 3 equals 0. So that's the zero product property. And then we get x equals 5 when we solve that equation, and x equals negative 3 when we solve that equation. So we have two numbers. 5, if you plug 5 in, so f of 5, you plug that in, we'd have 5 squared minus 2 times 5 minus 8. So you get what, 25 minus 10 minus 8, or 15 minus 8, you get 7, right? So that's like an ordered pair, 5 comma 7. So think about that, but when you plug in 5, you get an output. The input is 5, the output is 7. The same thing's going to happen if we plug in a negative 3. So if we allow x to be negative 3, we get negative 3 squared minus 2 times negative 3 minus 8, or 9 plus 6 minus 8, or 15 minus 8, which is 7. So it seems kind of weird that you could plug 5 in and get a 7 out, and you can plug negative 3 in and get a 7 out. But that's exactly what's happening with this function. So it's a quadratic function because it's x squared. And they asked us in part A, find x when the function equals 7. So here's one, and here's the other. Now part B goes right along with what we're saying. Find 2 points that lie on the graph of the function. So 1 point, remember your points are going to be x comma f of x. Think of that f of x like y. And so 1 point is going to be 5 comma 7. And the other point is going to be negative 3 comma 7. Now there's an infinite number of ordered pairs that will satisfy the equation, but we're going to use the work that we already did, so we don't have to do a bunch more work. So if you're like, well, I wanted x to be 1, you could do that and get another ordered pair, but we're just going to use the work we already did. So we know that when x is 5, f of x is 7. When x is negative 3, f of x is 7. Okay,